The next question in the series is why strongly acidic conditions are not favorable for the testing of aldehydes and ketones. Some of the important tests for aldehydes and ketones are reaction with nucleophiles. As for example, hydrazine is one reagent. This depends on the nucleophilicity of this on nitrogen. Phenylhydrazine is another reagent where we have the nucleophilicity on the nitrogen is being tested. So it all depends on the nucleophilicity, and hydroxylamine is another reagent where the nucleophilicity on the nitrogen of hydroxylamine will attack the carbonyl compound. Similarly, as we have seen in the earlier question, semicarbazide, 2,4-dinitrophenylhydrazine. These are all the various reagents wherein these are all called nitrogen nucleophiles because the nucleophilic site is on nitrogen. Hydrazine, phenylhydrazine, hydroxylamine, semicarbazide, 2,4-dinitrophenylhydrazine, like that. Question asked is why strongly acidic conditions are not favorable for doing this, for carrying out the reaction with aldehydes and ketones. They should be nucleophilic, but strongly acidic conditions, when we do a strongly acidic condition, what will happen is these nucleophiles are all protonated actually. This is no longer hydrazine, this will become NH3 plus. Similarly, this is not NH2, this will become also NH3 plus. So lone pair of electrons or free electrons are not available under very strongly alkaline conditions. I am sorry, strongly acidic conditions. Acidic conditions are not favorable because in strongly acidic conditions, the lone pair of electrons will get protonated. So one more proton will be added to this. This will become NH3 plus. So instead of the minus charge, which should attack the electrophilic carbon in the aldehydes and ketones, it becomes a plus charge, which becomes electrophilic in nature. Therefore, the nitrogen becomes electrophilic in nature and is no longer nucleophilic. Certain amount of nucleophilicity is needed because the basis of all the testing of aldehydes, the reactions of aldehydes and ketones depends on the nucleophilic character of these and depends on the electrophilicity of the carbonyl carbon and nucleophilicity of the attacking reagents. The nucleophilicity will get very much reduced or totally diminished on the addition of acids. Therefore, strongly acidic conditions are not favorable for testing of this.